Section 7-8, surface area of pyramids and cones. Now take a look at this. This is a drawing that Leonardo da Vinci drew back in 1485, and it shows a pyramid-shaped parachute. And actually in 2000, Adrian Nicholas proved that you could actually do this and descended from about 7,000 feet testing that out. So just another one of those things that Leonardo da Vinci did that actually worked. Came up with a lot of those. And if you don't know a lot about Leonardo da Vinci, you should learn. He was a pretty amazing scientist or thinker, I guess, back at that time. Several new things, again, vocabulary. You should write these out first because we're going to talk about some of these terms and you're going to need to understand what those mean. So it would be good to start by putting those in your notes right away so that you have that information in there. Okay, I'm going back into SketchUp, taking a look at our pyramid here. We've got a rectangular pyramid, and I just wanted to kind of point out, we're going to talk about surface area here, and I want to just make sure that you understand, as we look at this, as we look at our pyramid, make sure that you understand that as you look at this, let's say I'm staying on the blue line there, that is not the same as if I'm straight up and down. Okay? I mean, be aware of the fact that going straight down through this point and going down here, those aren't the same. So this area here is what we call the slant height. Oh, that's kind of hard to read. Slant height. And these sides, we would call those the lateral faces. So that's the lateral face when it comes to that. Okay, I want to make sure you kind of understand that. We're not talking about, once again, and unfortunately I can't spin and keep the drawing on here, but we're not talking about, straight up and down through here, is different than if I come down the face. Think of it like, if you're sliding down a hill, if you're sliding down this hill right here, that's not like you're going straight down in a tunnel down below. Okay, not the same thing. All right, let's get back to the book here. Okay, so here's our pyramid. And, we've got our vertex, our top. We've got the slant height. That's what I was talking about. This is on the face, the lateral faces. And then, of course, we have our base. And if we cut this pyramid apart, let's say we cut it apart at those lines right there, and then we lay it flat, it's going to look something like this over here. So our slant height is going to be this line right there. You've got your lateral face and you've got your base. And if we want to figure out the area of these triangles, that is known as the lateral area. The sum of all of those areas is the lateral area. We simply are finding the area of each pyramid that we have in that. And, understand, remember that a pyramid is 1/2 the length of the base times the height. All right, so let's take a look at an example. Let's say we've got this pyramid here. We know we've got a slant height of 15 inches and it has a base of 8 inches on there. So if we have to figure that out, it's a square pyramid, so it's 8 by 8. And if we've got to figure out the area, well, let's figure out the area of this triangle. Area of a triangle is 1/2 base times height. So 1/2 times 8 times the height. And this time we're talking about the slant height. We're talking about that, so it's 15. So 1/2 times 8 is 4. 4 times 15 is 60. Okay, so the area is 60, but there's 4 of them. This is a square, so there's 4 sides. So we would now take that times 4, and so our total lateral area is 240 square inches. Now, if we wanted to find the total surface area, we also need the base to to go along with it. So that would be, you know, it's 8 by 8, it's a square. 8 by 8 is 64. So my total area is 304 square inches on all of that. Now let's say you want to figure out the surface area of a cone. And when it comes to a cone, we need to know two things. We need to know the radius and we need to know the slant height. We call that L. And those two things, from those two things, we can figure it out. In other words, we need to know the distance from here to here and the distance from here to the edge of the circle. And from that area, we can figure it out. If you look at a cone, cones are, it's kind of interesting. You probably wouldn't think this, you know, if I just asked you without showing you, you probably wouldn't think that this is what it looks like. But if I take this cone and I cut it apart, you know, this is what I get. I get a circle, and I get part of a bigger circle. Now, how much of that bigger circle I get depends on how the size of this circle. And that's what I'm going to get for that's what a cone would look like if you had it taken apart and laid it flat. It would look like that. And to figure out, to figure out the surface area, I need to figure out the surface area of that, which is pi r squared. And I need to figure out the surface area of the lateral area, which is pi rl. So my surface area of a cone is simply pi rl plus pi r squared. It's those two things added together. All right, so let's find the surface area of this cone. If the radius is this and the slant height is 13, so radius is 7, slant height is 13, I simply plug the numbers in. I plug in pi, 3.14, r is 7, and L is 13. That gives me this part of the cone. If I want to figure out the other part, it's just a circle. It's pi r squared. So 3.14 times 7 squared. And I just simply add all those up. And if I calculate that out on a calculator, I'm going to get 439.8. So that's my approximate area. All right, that makes it your turn to do some problems here. I would like you to do A, B, and C. All right, so let's figure out the surface area of these shapes here. We'll start with A. And remember, when we're doing a cone, our formula for the surface area is pi r L, slant height, plus pi r squared. So if we put in what we know, all right, we know pi, 3.14. The radius is 5 feet. The slant height is 8 feet. Plus 3.14 times the radius 5 squared. And if I punch that into my calculator, I'm going to come out with the answer of 204.2 square feet. Now remember, surface area is square, volume was cubed, so on. Area is square. And since we've got this formula, let's work C. Let's work that one next because we've got another cylinder. So surface area for this one, 3.14 times the radius, 3.5 times the slant height, which is 10, plus 3.14 times 3.5 squared. And that's going to come out to be 148.4. So that's C, remember, so we worked it backwards. Now let's go back and work B. And if we want to figure out B, remember what we're doing is we're going to find the area of these triangles. There's 4 of them, and then we've got to figure out the base. And this is a square because you see we've got 11 and 11. So that's kind of nice. So if we're trying to figure out the triangle, each triangle is 1/2 times the base, which is 11, times the slant height, which is 18. And so if we get that, our base, 1/2, let's say half of 18 is 9, times 11 is 99, but there's 4 of those, so that would be 396. And then my base is going to be 11 times 11, which is 121. And if I add those together, 7, carry 517, and we're talking about millimeters squared. So there's our 3 problems that you had to do. I think we need to do just a little bit more. So would you do numbers on page 354? Okay, 354. Would you do, let's just do 3 and 5. 3 and 5 on page 354. Just to get a little more practice in on these. I think they're kind of tough. I think we need to do a little bit more. Make sure you put these in your notes. I want to check those. Make sure that you know what you're doing.